Hi again. This is Tina again. I don't need design details. Boy. This is Tina. Today we're going to talk, right now we're going to talk a little bit about scientific notation. So we spoke last time about exponents and how you can have a variable raised to a power and it actually means a times a. So with scientific notation, we use the base 10 a lot. And for 10, we raise it. If we were going to do that, it's going to be 10 times 10, which is 100, right? Pretty simple. If I tell you I want to multiply 2 times 100, or 2 times 100, the answer is 200, yes? Pretty simple in both cases. Remember, I changed the notation from an X to a dot in the last thing. So this is what that means. I can also rewrite this as 2 times 10 to the 2, which basically means 2 times 10 times 10, which is also 200. So it's fairly simple. It's a shortcut way that we write stuff out. Now we are 93 million miles away from the sun. That is 93 million miles. If I would like to express that in scientific notation, which we don't really do with miles very much, but we do with kilometers and meters and stuff, there's a little trick we do. So I've written out 93 million miles here. I'll put the miles. And I've added a decimal point. So the decimal point right here is actually an addition to there. Usually, if it's a whole number, you don't put a decimal point, but I'm going to put one because I'm going to demonstrate to you how to convert this number into scientific notation. So the rules for scientific notation are that it's a format of a number, a decimal place, and numbers. And the amount of numbers back here kind of depends on the number that you're starting with. But there is one number before the decimal point. That number is between 1 and 9. So you don't have a 0 and you don't have a 10, just 1 through 9. If you do have a number 10, you move it again and you get a 1 back, right? So we take this number, 93 million miles, and I move the decimal point. 1, 2, 3, 4, 5, 6, 7 times. So I get my formula, 9.3 times 10 to the, how many times did I move it? 7 miles. That is scientific notation. So if I have something that's 899,000, let's put that number, kilometers. What if I write that in scientific notation? Well, we do the same thing. Start here and I go 1, 2, 3, 4, 5, because I want to have the formula here where there's a number, a decimal point, and then whatever numbers. So now this is written 8.99 times 10 to the 5 kilometers. The reason why we do that is because it's shorthand notation. We do have some things that end up being 10 to the 26 kilometers. That means there is, so say this is 3 times 10 to the 26. That is 3 with 26 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So the reason why we use scientific notation is because this is a bear. How in the world, if you wanted to know, you'd have to count in order to know if it was 25 or 26. And it's just a real big pain in the butt. Let me put the commas there. Comma, 1, 2, 3, comma, 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 oops, comma, comma, comma. So anyway, it's very hard to read that. And so that's why we've developed the scientific notation. Now this is for large numbers. Our exponents, if you see here, it's a positive number. I'm going to go back here. I'm going to add a slide and we're going to add this now small numbers. Okay, so small, I told you before that that in astronomy, we deal with really small numbers like nuclear atoms, molecules kind of thing, wavelengths. gamma rays. Those are very, very small things. We also deal with really huge things, galaxies, the universe, the size of the sun, very large things. So small numbers, though, can be like if we're going to go a millionth of a meter or a nanometer. I mean, those are a whole bunch of zeros. I'm not even going to count. Well, I will count eventually. I'm adding a bunch of zeros and then I'll put a 1, right? And so this is some fraction of a meter, the meter stick that we had before. We were broken up into this many decimals. And so how do I write that as a scientific notation? Just because this is a bear to read, you can't really understand it, right? So we do it the same way, except it's a little different. So I start at the decimal point and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 1 times 10 to the negative 20 meters. Okay, so remember our formula, we have to have a number between 1 and 9, a decimal point, and some other stuff. And this one, we just left it off because it's a 0. So if I have 0.4587 and I want to write that in scientific notation, I move it 1 point and 4.587 times 10 to the negative 1. If I have 0.00487, oops, I forgot the 5, but same thing, 1, 2, 3 now. So it's 4 times 87 times 10 to the negative 3. Okay, so when you see negative numbers, those are really small numbers. When you see positive exponents, those are very large numbers. Of course, the larger the number, the larger the number, the larger the negative number, the smaller the number. All right, so that's scientific notation. Let me know if you have any questions, and good luck on your lab.